Hi everyone, this is Hossein from Ija Academy. So I'm here with Amir.
Hello,
How are
Hussein.
you, Amir? How
Good.
are you? Okay.
Yes.
Yeah. So Amir, thanks for being here. And
Sure.
so I have a problem in limit, and I want you to help me and explain the problem for me and the audience, and hopefully everybody enjoyed this video. So the problem is finding the limit of this expression 6 to the x minus 5 to the x divided by 4 to the x minus 3 to the x. And probably you're going to use L'Hopital rule to find the limit, because this is one of those indeterminate limits. And then, so if you can also use a graph to, confirm the answer, the solution, that would be great. So the floor is yours.
Okay, sure. Thanks for explaining this one. Limit of numerator divided by denominator. We have 6 to the power of x. When x approaches to 0, is going to be 1. So this is going to be 1. This is going to be 1. So in the numerator, we have 1 minus 1, which is 0. And in the denominator, we have the same, 1 minus 1. So 0 divided by 0. So we satisfy one of the forms of the L'Hopital rule to use.
Right.
And of course, both numerator and denominator functions of differentiables. So we have two indeterminate forms to use L'Hopital. One is 0 divided by 0, and the other one is infinity divided by infinity. And in this case, we have 0 divided by 0, as I explained.
Right.
So I'm going to start solving the problem. We can use the L'Hopital rule. So in other words, we take derivatives of the numerator and denominator.
Right.
Limit of 6x 5 to the power of x, 4 to the power of x, 3 to the power of x when x approaches to 0. I can actually differentiate these terms in the numerator and denominator. So for this function, let me write in the side, when we have a function of y in terms of x equals a to the power of x, when a is actually positive, I guess.
A constant, right?
Yeah, constant.
Mm-hmm.
Then the derivative of that one is ax ln of a, natural logarithm of a. So given this one, for this term, we have 6 to the power of x ln of 6 minus 5 to the power of x ln of 5 in the numerator. And then in the denominator, the same rule, 4 to the power of x ln of 4 minus 3 to the power of x ln of 3. And when we use the L'Hopital rule here, we check again the value of the limit to see what we get. If we get one of these forms, we can again use L'Hopital rule.
Right.
If not, then we have the answer. So here, when x approaches to 0, this guy is going to be 1, correct?
6 to the power of 0.
Yeah, so it's going to be 1. This one is 1, and this one is 1.
Right.
So, and then we have a constant value for the limit. So, in other words, we obtain the answer.
Right.
Therefore, let me write it down like this. I'm gonna actually apply the limit to the functions. So it's going to
Okay.
be 6 to the 0
Mm-hmm.
ln of 6 minus 5 to the power of 0 ln of 5 4 to the power of 0 ln of 4 3 to the power of 0 ln of 3. And since I applied limit, then I don't need to write the limit in here. So it's going, these values, 6 to the power of 0 or everything constant value to the power of 0 is going to be 1. So I have ln of 6 minus ln of 5 divided by ln of 4 minus ln of 3. So I just need a calculator.
Okay, let me see if I can help you with that.
Okay,
So
thank you.
6 divided by 5, and then ln. So I'm going to calculate, give you the answer for the numerator and denominator separately. For the
Sure.
numerator, you have 0.182, 3 decimals, and then 4 divided by 3. And the denominator is 0.288.
Yeah. And then we have the
So
final answer.
The final answer is 0.632.
Okay, cool. That's the actually answer for the limit, for this limit.
Okay.
That
Then
actually answers the first part of the question.
mm-hmm.
Then you asked me to actually draw the function, the graph of the function, to see when x approaches to 0, what I get. So I'm gonna use Desmos
Okay.
to do that. So I go here. This is Desmos. Hopefully our viewers are familiar with Desmos. That's very useful.
Yeah, that's a great tool, actually.
Yeah. So in here, I'm gonna define the functions. So I had
6 to the x
6
minus 5 to the
to
x.
the x minus 5 to the x.
Then the whole expression divided by 4 to the x minus 3 to the x.
4 to the x minus 3 to the x.
Cool.
Close the bracket. And then let me just...
So when x approaches 0,
I don't know why it actually happens like that, but it has a rendering problem. I don't know why, but anyhow, this is the curve. Let me just take a picture of that, and then I go back to my GoodNotes, and then let me just insert.
Maybe if you crop the, those areas that you don't need. Can you do that? I see like a small arrows on the top and on the right side. Oh, it doesn't work like that.
Yeah, doesn't work like that. But
maybe on the graph it was more clear to read the numbers.
Yeah, okay.
If you still has it open.
we have this value.
Yeah, 0.63.
And this is 0 here.
Mm-hmm.
You see the y-axis, so it's 0, and it intercepts with a y-axis at like,
Yeah.
yeah.
So can you, I don't know if you have a highlighter or something, or no? I don't think your highlighter
Let me
works. Or
see.
maybe
I
your
can do this.
mouse
Yeah,
pointer, huh?
I can do this, and then I just crop it here.
Okay.
Yeah, let me crop it here.
Oh, okay. Now it's clear.
Yeah, and then
Awesome.
so yeah.
Okay. That's one of the, advantages of being an engineer. Always find a way.
Yeah. This one is actually
0.6.
0.6, and then we have 1, 2, 3,
Mm-hmm.
and then the point here
Yeah,
is
0.632.
0.63. Yeah, 2.
Mm-hmm.
So with very good estimate, actually, we can see
Mm-hmm.
that the graph answer, that's graph of the function, really matches well with the L'Hopital rule answer.
Right. And
Of
the
here.
left side, I see the limit from the left side and the right side, both are the same, both approaching 0.632.
Yeah.
Yeah.
So
All right. Thank you, Amir. I appreciate that was very clear, and it was really helpful understanding the problem. And
sure.
to the viewers, this is all for today. I hope you enjoyed this video. Please don't forget to hit the like button and also subscribe to our channel for future videos. Till next video, bye everyone.
Bye. Thank you, Hussein.